Yo, folks, you're going to collect some data right now for a free-falling object. Unfortunately, it looks like it's falling to the left. And double, unfortunately, this numerical scale is upside down. And triple, unfortunately, it's a little bit blurry. But you are a scientist, and you overcome obstacles like these. At least you will. Okay, so here's that smooth steel sphere. We're dropping it, and it's going to fall through space. Wait, come on. Fall through space. Whee! All right. And what you need to do is find its position. This video is shot at 60 frames per second. You need to find its position at intervals of 1/60th of a second. All right, we did a Let's Roll lab at intervals of 1/10 of a second. This is at 1/60th of a second. Now, just so we can read this thing maybe a little clearer, here's 10 centimeters. Here's 5. You can see the 5 increments are a little bit darker than the surrounding ones. So what's going to help in a lot of cases is to really actually to like identify either the 10 or the 5 and count back from there. And notice, for example, here's 55. Well, this is 54, 53, 52, 51, 50. All right, which means this is 55, 54 and a half, 54, 53 and a half, 53, 52 and a half, 52, 51 and a half. You get the idea. All right, so you can get down to, at the bare minimum, halves of centimeters. And what I say is, ideally, you ought to be able to say, let's look at the left edge of this cursor. If the left edge of the cursor is like there, well, let's see, that's 45, 46, 47. It's between 47 and 47.5. So I think, well, not I think, but the appropriate expectation here is that you estimate really where it is between those two. So I would say, hang on, 45, 46, 47.1, 47.2 maybe. All right, that involves some uncertainty, which is okay. We can't be positive about what our answer is because there's no way to be positive. So what I'll ask you to do is, if you think it's right on the line, fine, call it 0.5. Or sorry, that would be 47, 47.5. But in between, do your best. All right? If you just want to say, all I can tell is on the line, or between the lines, then you'd call that 47.25, sort of no matter where it is in there. There's nothing wrong with that either. Okay? So what you're going to do is we're going to start, notice I just released the ball. See it? Boop, released it. I'm cursoring forward and playing this one frame at a time. All right, so I release it. I want you to start your time 0 right here. This is time 0. The leading edge of the ball is pretty much at the edge of this thing. I wish it were right on, but it's pretty much there. All right, so we're going to look at where the leading edge of the ball is. All right, here's time 0. It's at position 0. All right, here's 1/60th of a second later. All right, where's the leading edge of the ball? All right, boom, it went that far. Now, I do understand there's this shadow right here. That's a shadow of my finger, unfortunately. Leading edge of the ball is about here. All right, like I said, counting back from 5 can be helpful. Here's 5, 4, 3, 2, 1. Maybe it's, I don't know, between 0.5 and 1. Looks like it's past this little 0.5, doesn't it? But not all the way to 1. So make your best judgment there. And you need to write this down right now. You need to record this data. And what I recommend is the following. I recommend a data table that looks something like this. For now, it doesn't have, you're not going to hand this in, but what you're doing is recording. We'll do 20 positions at 60th of a second. Whoops, 60th of a second intervals. 60th of a second. Okay, that's going to go in an Excel spreadsheet later, looking like that. Okay, so we got, oops, here's time 0, first 60th. You have your measurement? Here's the second 60th. Remember, try to count. Hey, stop that circling thing. You got to count back from 5. I wish I could show you where 5 is. Escape, that's probably no good. So 5 is at the top of this circle. 5, 4, 3, 2. A little bit before 2, maybe. Maybe right on 2 by your judgment. Okay, so that's, again, 0, 1/60th, 2/60ths. There's 3/60ths. Again, count back from 5. The very top of the circle is 5, 4. Well, that next line is 3.5. You think it's all the way there, call it 3.5. You think it's a little bit before there, call it 3.4 or 3.3. I'll even back up for you. There's the 3. You can actually see the very edge of the 3 in this top corner, that little sliver up there. All right, so we have now 0, 1, 2, 3/60ths. Here's the 4th 60th. Make your measurement. Here you might want to count back from 10, 10, 9, 8, 7, 6, 5. Here's next. Here's next. If you need to pause, feel free. There's no reason for me to sit here waiting, right? You might as well pause and make your measurements if you have to, so I'll pick up the pace a little bit. I'd call this one 15, 14, 13, 12. I'd call it 12.0, personally. If you think it's different, feel free. Pause if you need to. Pause if you need to. Pause if you need to. Okay, that should be 19/60ths. So including 0/60ths up to 19, that gives us 20 data points. I say very sufficient. Okay? So, you should have stuff written down, and we're now going to, the other video you're going to watch is going to show you how to put this data into Excel and how to process that data. All right, and your target by the end of this is to have the following. On Monday, you'll have the following when you walk in. You'll print one sheet of paper that has your data. You can do time in 60ths or time in seconds, up to you. And then it will have a position time graph and a velocity time graph. And each of these graphs will have a best fit and an equation of that best fit on it. The point of this is to find G, right? We're going to find G most straightforwardly, that's not a word, but most simply from that graph. Remember, G is an acceleration, all right? So that graph can tell us acceleration if we know what to look for. Okay? That's for Monday, folks. So look, the other what do you call it? The other video is called Excel Tips. All right. Now, hey, the one thing on that video is I don't talk about this. Remember, I don't care what that's in. X, I don't care what that's in either for now. All right. What we're going to eventually do is find, just like we did in the Let's Roll that, find the instantaneous velocities, sort of the instantaneous velocities. I don't know, let's call this x1 and x2. All right, if you remember, we said, okay, this is going to be, well, the instantaneous velocity is going to be x2 minus x1 over, well, t2 minus t1. All right, but remember what we said in the Let's Roll analysis that it doesn't say in this Excel tips video you're about to watch, is it doesn't say, remember how we said, when does it have this velocity? Well, it doesn't have it at this instant or at that instant. It has it at that instant. Remember that? So if you want to include that to make it really a more realistic representation of what that nice smooth steel sphere was doing, that'd be my guess. I encourage. Okay? Okay. I think that's all. Good luck.